Hey students, I had actually a GED graduate. She's a college student now, but she's sending me this problem from her online college classes. And turns out her, I guess, professor is not doing a great job explaining. So Charlene, this one's for you. We're going to explain this particular problem two ways. First, we'll look at it visually, and then we'll look at it a little more mathematically, although don't get me wrong, using visuals is very mathematical as well. Let's go ahead and take a look. It says, which of the following are equivalent to 3/12ths? And Charlene says, I know the right answer, but I don't understand the explanation. So let's go ahead and take a look here. The first thing I'm going to do is draw a visual representation of 3/12ths. And a lot of people like to use pies when they're visualizing fractions, but pies can actually get confusing to draw depending on how many pieces you have to cut it into. So you guys, I'm going to use chocolate bars. So what I'm going to do is I'm going to visualize 3/12ths. And then I'm going to draw a visual of all the other ones. Now it's important that I use the same size bar. One whole thing should look like one whole thing, always and forever, if I really want to see if these guys are going to be equivalent. So, oh my gosh. And this maybe is why I'm not a geometry teacher. My chocolate bars don't fit. So, I forgot to do 1/4. So we'll do the 3/12ths up there, and then we will draw a diagram of 1/4 and of 3/8, and then we'll try 5/16. And don't worry, I'm going to show you a mathematical way that you don't have to go through all this work every time, but I just want to give you the visual first, because a lot of times people who understand this visually intuitively know what the right answer is even without doing the math. Okay, so let's talk about the first one, 3/12ths, the one given to us in the problem. What does it mean to have 3/12ths? Well, it means this one whole thing, this chocolate bar, if you will, has been broken into 12 pieces. So the 12 is the number of pieces in the whole. And of those 12, I have 3 of them. I have 3 out of 12 pieces. Okay, so that being said, the first thing I'm going to do is break this sucker into 12 pieces. And I'm going to try my best to make sure that they're equal pieces, or I'm really not doing fractions justice. So I think I'll do it into fourths first, because half and half again gives me fourths. And then by breaking each one of those into 3 equals, I should get a total here of 12. Okay, so I've broken this into 12 pieces, and what does it mean to have 3/12ths? Well, it means that I have 3 of those 12 pieces. Now, let's compare that to the next one, 1/4. Well, what does 1/4 mean? Similarly, 1/4 means that my chocolate bar has been broken into 4 pieces, 4 equal size pieces, and of those, I have 1 of them. So let's break this sucker into 4 equal size pieces. And of those 4 pieces, I have 1. Look at how those 2 green boxes are just the same size. You know, I can talk about it as 3/12ths, breaking that chocolate bar into 12 equal pieces and taking 3 of them, or just breaking it into 4 pieces and taking 1 of them, but I'm taking the same amount of chocolate. That's equivalent. Now, let's go ahead and compare it to the other examples. Like, let's look at 3/8. 3/8 means I'm breaking into 8 equal pieces. So let me break it in half, then those halves in halves, and then those halves in halves. Here we have 8 equal pieces. And of those 8 equal pieces, I have 3 of them. Let me color it in. 1, 2, 3. Close to the same amount, but not exactly. This is a little bit more. This is not equivalent. Let's check out the next one. 5/16. So now I have to cut my chocolate bar into 16 equal pieces. So, oh my goodness. Halves. Half those halves, that gives me 4. Half those halves, that gives me 8 equal pieces. And then half each of those halves, and that will give me 16. Holy moly, that's a lot of pieces. Okay, so 16 equal pieces. And of those 16 equal pieces, I have 5 of them. Now, once again, we're super close, but we're not exactly there. You know, exactly there would be this line, and I've got a little bit more with 5/16. So this guy is close, but not equivalent, a little bit greater. And 5/8 is way off. Let me show you what I mean. So 5/8, so let's cut this sucker into 8 pieces. So halves, now half it again, and I have quarters. Half those again, and I have eighths. And now 5 of those eighths will put me way out here. 1, 2, 3, 4, 5. Way more than 3/12, not even close. And so a visual representation of why these two are equivalent is right here. So 3/12 and 1/4 are equivalent. There it is visually. Now, like I said, you're not going to have time all day long to do this this way. So my general recommendation for this is just to reduce the fractions. If you just reduce all the fractions, it's really easy to see what is equal. I'll show you what I mean. Reducing is dividing out any common factors. So, for example, I know that 3 and 12 have a common factor. They're both divisible by 3. What do I mean by that? They're both on the 3 times tables. You know, if I count by 3, 3, 6, 9, 12, both those numbers are on there. So any common factors can be divided out. If I take 3 divided by 3, I get 1, and 12 divided by 3, I get 4. And look at that. 3/12 is exactly equivalent to 1/4 when I reduce fractions. Okay, and then what if you don't like reducing fractions? You're like, I still don't get it, Kate. You can also always do the implied division. What is Kate talking about? Well, guys, a fraction bar means divide, literally. 1/4 or 1/4, yeah, you can draw a picture for it, or you could just be a lazy mathematician and use the divide button. A fraction bar means exactly the same as divide by. So let's do it. 1 divided by 4. You know what I get? 0.25. So that was right here. 1 divided by 4 is 0.25. Well, how about when I do 3 divided by 12? 3 divided by 12. Guess what I get? 0.25. It gives me the exact same decimal because it's the exact same relationship. Now, I mean, if I were to do another number, 3 divided by 8, I'm going to see I don't get the same number. I get something a little bit more, just like we expected from looking at our diagram. Or 5 divided by 16. Again, close to 0.25, but yeah, a little bit above. And then, like we said, this one's going to be way large. 5 divided by 8, that's 0.625. That's more than double. And we can see there a third way. Oh, look, I told you I'd give you 2 ways, and I give you 3 ways to look at equivalent fractions. 1, we can look at it as a picture. 2, we could just reduce all the fractions to lowest terms. If we reduce all the fractions to lowest terms, the ones that are equivalent will reduce to the same thing. Or 3, we could convert all the fractions to decimals by doing the implied division. And y'all saw I did not do that by hand. I picked up my calculator because I don't have all day. All right, if you have any questions about this or any other GED math topic, be sure to drop it in the comments and I'll do my best to answer it.